Alright, so welcome to the second lecture of this course, and in this lecture we're just going to learn how to download Python. So the reason we need to download Python is because we have to get that IDLE in which we write the Python code. It's absolutely necessary to download Python before we start writing any of the Python syntax. So first thing first, what I want you to do is head over to python.org. And what python.org is, So what python.org is, it's basically the official site of the Python programming language. Over here you can have documentation, you can download stuff, and it's a really nice place. So I definitely suggest later on, whenever you're free, check out the site. You can check out the documentation, the community, some success stories, stuff like that. But what we're going to be doing is, if you scroll down a bit, or you can just go ahead to the download section, and you're going to download for Mac OS X 3.4.3. Now, if you're on a Windows, it should probably say download for Windows 10 or Windows 8, whatever your version is. And you want to select Python 3.3 over here. In case you're not seeing something, what you can always do is scroll down a little further, and you'll see this download icon over here. Go ahead and select Python 3.4.3. So it says all this good stuff. It was released on February 25th, 2015. Major new features, stuff like that. We don't really have to use any of that. Basically, take a look at this stuff, the files. So if you're on a Windows, definitely use the one that was for an OS Windows. So probably the Windows x86-64 MSI installer, or you might do the one underneath that, the Windows x86 MSI installer. So if you're on a Windows machine, definitely click one of those. If you're on a Mac OS X, obviously do the one which has the Mac OS X. So I do have the latest version of Mac OS X, which is higher than 10.6, so I'm going to select this one. Okay, and again, it just depends on your machine, what you have. And now you're going to see a package being installed over here. So it has a 3.4.3 package. And I'm not going to go through, or I'll just open this for you, but I won't be going through the steps of installing Python 3.4.3 again, since I already have. But the concept is quite simple. Same thing for a Windows machine. The package will download. All you need to do is go through the steps, go through each one of these steps, and once it's downloaded, you should be able to see it. So for Mac users, I'll quickly show you how to get to it. Let me just get this file over here. Okay, give it a few seconds. So going into applications, over here, you're gonna see Python 3.4 appear. Okay, so right now my machine is taking a little bit of a longer time than usual. However, if you're on a Windows machine, you're gonna go into your C drive or D drive or whatever your main hard drive disk is, and over there you're gonna see a folder called Python 27 or Python 34. So if you select that, that's where all your IDLE and Python launcher and stuff will be. So as you can see, now my Python 3.4 package has been installed. I have my IDLE, my Python documentation, my Python launcher, and so on. So for the coding part of Python, we'll be doing our maximum coding inside of this IDLE. Okay, so it's over here where we write the code. I'll quickly show you how the IDLE looks like. It's bouncing around right now. It's going to take me a little bit of time. But basically, throughout this course, we'll be using this IDLE to write all of our Python code. Okay, so this is how the IDLE looks like. As you can see right now, I'm using Python 3.4.3. If you hit enter, this is where you write code. So I won't be showing you the code in this lecture. This lecture is all about downloading Python and installing it on our machine. Now, in the next lecture, we'll go ahead and create a very simple Hello World program. See you then. Alright, so in the previous lecture, we learned how to install Python on our machine, okay? And right now, in front of your screen, you should have your shell open. So I'm not going to take too much time here. Basically, I'm going to create a Hello World program. So in almost every single programming language, the first step a beginner takes is creating a Hello World. I'm not sure why that is, but it's always there. So let's go ahead and do that. Basically, we're just going to print out Hello World. So it's not too complicated. What I want you to do is type print, okay, so P-R-I-N-T, and then in brackets, put in quotation marks. So print, bracket, and then quotation marks, hello world. Hello world, okay? So basically what we're doing is we're calling the print function, and we're printing out hello world. There we go. So as you can see right from the start, the syntax of Python is very easy. It's pretty straightforward. I mean, as we go on to more beginner and advanced concepts, you'll realize, hey, Python is actually really easy. So this was a simple hello world program, and this was the end of section 1. So we just learned how to download Python. There was a welcome lecture before that, and in this lecture we learned how to create a very simple hello world program. There was nothing to teach you actually, I just wanted to get that done with. And in the next section we'll move on to the basics of Python. So variables, strings, lists, dictionary, stuff like that. So that's it for my side, and see you in the next section. Hi guys, Avi here. Now, if you've already had some experience with Python, you know how things work, go ahead and skip this section. Basically, if this is your first time programming, or if this is your first time dealing with Python, then this section is for you. In this section, we plan to cover all the basics of Python, from variable types and loops to functions and classes. Now, let's get started. So, in this lecture, we're going to be talking about variables. First thing first, what is a variable? Now, if you've dealt with any programming language before, you know what variable is. A variable is a reserved memory space. Okay? Now, this memory space can hold any value, and it is assigned to a term. So, for example, I can create a variable called maybe my age, so age, and I can set that equal to anything I want. I can set it to maybe a text, so I can set it to some text. I can set it to my actual age, which is a number. I can say age is equal to 14. So here what we've done is we've created a variable whose name is age and whose value is 14. Now, wherever in the Python program I call on age, I'm going to get the value as 14. Okay? Now, the neat thing about variables is you can always change the value. Remember, variables are not permanent. Variables are changeable. So I can now say, hey, my birthday was yesterday. I am now 15 years old. So age is now equal to 15. And if I print out age, I get the value as 15. So this is key. Now, while assigning variables to Python, the concept is very, very simple. First part is the variable name. It can be Bob. It can be John. You can have a capital letter. You can have all caps. Doesn't really matter. You just need an identifier. Now, if I try doing maybe like print is equal to something, I can't do that because print is a function in Python. So these are, the case does matter when you're assigning variables, but however, stick to some normal names. Maybe if you're trying to get a print variable, then my print or something like that. Now with variables, it's very simple. It's a 3-step procedure. You write your identifier, or a variable name, a var name. You use an equal sign to say that, hey, I'm assigning the value to the variable var name, and then what you do is you give it its value. For example, I'm creating var name as an integer with 12. So something like that. Alright, fantastic. So in this lecture, we just gave a very, very brief introduction to variables, how to assign variables, and what variables are. Now, in the next lecture, we'll talk about multiple declaration of variables. See you in the next lecture. Alright, so in the previous lecture, we talked about variables and how to assign them to values. Now, the question comes, let's say you're dealing with a big Python project, and you have to create variables of every single person in your class. Let's say you have 10 people, and each one has, different names. So it's a very tedious project. What you do is maybe something like person 1, set that equal to maybe Abby, person 2, set that equal to James, and on and on. So this would continue on till person 10, and by that time you would have collapsed and you'd be groaning, oh my god, I hate Python. Well, that's not the case. Here we talk about multiple declaration. And all it does is you can assign multiple values to multiple variables in one line. Now, the way it works, well, you can do something along the lines of this. Person 1, person 2, person 3. And I want to set person 1, person 2, and person 3's value as Abby, James and LeBron. Okay, so once I do this, if I now say person 1, I get Abby, person 2, I get James, and person 3, I get LeBron. You see how it made our work a lot more easier? We didn't have any problem of declaring variables. So this is a very nice feature of Python, multiple declaration. Now let's say we had another case. You had one string. Let's call that string as apples. And you had 10 variables. And what you wanted to do was you wanted to assign apples the value to all the 10 variables. So something along the lines of this. var1 is equal to apples. var2 is equal to apples. Whoops. Okay. var3 is equal to apples, right? And so on. So right now, as you can see, it's giving me an error. var3 is equal to apples, invalid syntax. If you haven't guessed already, let's just go through this error as a learning process. You cannot give spaces while implementing or creating your variables. Your variables must be one word. You can do maybe something like my name is, so joining all the words together, but in the end, your variable name must be one word. Anyways, going back to our main point, we wanted to set each variable, var1, var2, and var3 as apples without having to do it repetitively. How would we do that? Well, there's also the concept of multiple assignment, where I can say var1 is equal to var2, whoops, is equal to var2, is equal to var3, which is equal to apples. Isn't that neat? So now, if I call on var2 or var3 or even var1, all three of these variables have the value of apples. Fantastic. So let's quickly recap what we learned in this lecture. We learned about multiple declaration, where you can assign 3 variables, 3 different values in just one line. And then you also learned about how you can do multiple assignment. 3 variables can also have the exact same value. Fantastic. So in the next lecture, we'll talk about data types. If you don't know what data types are, let me give you a quick hint. What we have been using so far have all been data types. See you in the next lecture. Alright, so let's go ahead and get started with data types. Right now, I think the shell is looking a bit crowded. So what I'm going to do is, I believe there is an option for me to restart shell, but that won't do anything actually right now. So I'm just going to close my IDLE, or yes, and I'm going to reopen this again just to make it a bit more easier for you guys so that you're not too confused about what's going on the screen. So my IDLE is taking a bit of time to load. There we go. And let me get into the screen size. All right. So we're now talking about data types. So what is a data type? Well, the data stored in a variable, right? Our age variable, our name variable, can be of many types. So far we've dealt with numbers, right? And we've dealt with text, which we call as strings. The remaining 3 main data types, or the standard data types, are lists, tuples, and dictionaries. Now we'll get to these 3 later on in the following few lectures. Right now we're just talking about numbers. This whole lecture, let's just talk about numbers. How does this work? So we've already dealt with the basics of numbers. So age is equal to 10, var him is equal to 15 or 35. So you know the basics of how to add these numbers, right? And that's basically the core concept. Now what we want is we want to learn, hey, how do I add variables? How do I subtract variables? So the way we do that is with something called operators. Now, you must have learned probably in pre-K actually what operators are. Addition, subtraction, multiplication, and division. The 4 simple operators. So what I'm going to do is I'm going to create 2 variables, age 1, set that as my age, and age 2, set that as maybe I believe my dad's age, which is 40. And let's say I gave you the puzzle, create a 3rd variable, age 3, which has the sum of age 1 and age 2. How would you do that? Well, to the layman, it's sort of obvious, but with Python, it's quite simple. the way we're going to do this is age 3 is going to be equal to age 1 plus age 2. So this is where we use operators. Now, if you print out age 3's value, we get 54. It's that simple. Now, we've used addition. Let's use subtraction, multiplication, and division. Age 1 minus age 2, what do we get? Minus 26. Age 1 divided by age 2, we get 0.35. And age 1 into age 2, again, note, the into sign is an asterisk sign that you get by shift 8. We get 560. Now, the last operator I want to talk about here, at least for arithmetic operators, I can't speak today, is modulus. So the modulus operator, all it does is it gives you the remainder of a division, okay? Right now, we divided age 1 by age 2 and got 0.35. What do you think the remainder is when we divide age 1 by age 2? Well, if you're good at mathematics, age 1 mod age 2, which is percent sign, you're going to get 14. Why? Because 40 or 14 is not divisible by 40 in the sense that not even by 1. So you get 0, remainder 14. Okay? So these are the main 5 operators that you're going to use in Python. Now, in the next lecture, we're going to be talking about strings. So adding strings, how strings work, and stuff like that. See you in the next lecture. Hi guys. Now, before I start, I just want to point out Python is a fantastic language to learn. Now, if you're learning this as your first programming language, that's amazing because Python is probably, for my sake at least, one of the easiest programming languages to learn. Now, let's get on to strings. So, strings in Python, as we've already seen, are characters denoted in quotation marks, right? So I could say a variable my name and set it in a value of quotation marks, some characters, right? Let's do my actual name for Python's sake. And we've talked about adding, so operators, addition, stuff like that. So my quiz or my question here right now is, I'm going to create a variable, first name, set that equal to Avi. I'm going to create a second variable, second name, set that equal to Jane. I should have actually created the last name, but that's fine. And now what I want you to do is create a variable called full name, which has the sum of full first name and second name. Now, if you're already a step ahead of me, concept's quite simple. First name plus second name, and if you now print out full name, you get Avi Jane. So you see this error of a space, right? And probably the easiest way we can get rid of that is by adding a quotation marks in the middle with a space. So first name plus quotation marks with a space plus second name. So now if we print out full name, we will now get Avi Jane. Awesome. Now the question I give to you is, suppose I give you this text, Avinash, and then gibberish, okay? And the goal, or sorry, I was actually supposed to assign that to a variable. So random should be equal to, and then let me just copy this, Command C. All right, random is equal to Avinash, gibberish, blah, blah, blah. And the goal I'm trying to give you here is, hey, I want you to return me Avinash. That's it. I don't want any of the gibberish stuff. I don't want the space I have over here. All I want is this clear and simple Avinash. How do I do that? Well, thanks to Python, we now have the slice operator. Now, the core concept of slice is you can get or you can slice any part of the string from wherever to wherever. The way it works, you type in random and then you type the 2 square brackets. And in the square brackets, let's go give it a try. So I'm going to go through several example cases so that you get the idea of what's happening, and then we'll actually slice out Avinash. Now, first example case. Let's say you just wanted the first letter or a single letter. Hey, what's the 10th letter in this statement? You're going to say random 10. What does it give out? B. If you actually wanted to count, Avinash is 7, 8, 9, 10. So you're probably wondering, hey, Avinash is 7 plus the space 9, 10. Why has it given me B instead of what I think is I? And the reason it's done this is is because the indexing of almost everything in Python starts at zeros. When we get to arrays or actually lists and dictionaries, indexing starts at 0. So think about it like this. The first character in the string, its position is the 0th position, then 1, then 2, then 3. For example, now if I wanted to get the actual 10th position, I do 10 minus 1, right? If you wanted to get the xth position in the string, you do x minus 1. It's that simple. So if I wanted to get the actual 10th position, I do random 9 and I'd get I. Cool. So the next case is I want to get a slice. Let's say from the first character to the 4th character. How do I do that? Well, we've talked about this. So what's the first character in the list? Well, the index position is 0. So we do random, and then using the slice function, we do 0. Now we say colon, hey, we got the first position, where do we want to go up till? Well, we're going to say, let's say I want to go to maybe the, let's say Avi. So I believe that's the 3rd. So 0 to 3, 0, 1, 2, 3, but it won't count the 3. Exactly. So the slice function here, what it's saying is, give me the first position, right? So where do you want me to slice from? And then give me 1 after your end position. For example, I wanted Avi. A is 0, V is 1, I is 2. Instead, I gave 0 to 3 so that it returns me 0, 1, 2. The last one, 3, isn't counted. Now with this knowledge, go ahead, do a quick challenge here. Give me Avinash, or whatever statement you've given me, or written, give me your name. So I'm going to pause the video. You should hopefully do this. It's actually just one simple statement. Let's take a look. Alright, hopefully you managed that. If you didn't, that's absolutely fine. We're going to do random 0, okay? And like I've talked about, my name is how many characters? It's 7, right? So let's go ahead and put in 7. Now, if you realize, I've already thought one step ahead. So 0, 1, 2, 3, 4, 5, 6, and then one more, which is 7. So 0 to 7, and I get Avinash. Fantastic. Now, before I end this lecture, there's one more thing I want to cover. Let's say I wanted everything from the 3rd character. So I wanted Nosh gibberish. What would I do then? Well, it's actually quite simple. I'm going to use the slice function and say random from the 3rd character, which is 2, to everything after that. Random 2 colon. And once I do that, I get Inosh, gibberish, blah, blah, blah. So these are a few simple functions that you can use with the splice. So whenever you have a string and you're trying to get a specific string out of that string, you can use the splice function. Fantastic! So we learned a lot in this lecture. First thing first, we learned about strings, how to add strings, adding that extra gap. After that, we learned how to get a specific string out of the main string. So searching and splicing. That's the core concept. Nice. Now, in the next lecture, what I want to talk about is the next data type. So we've discussed about integers, we've talked about strings. Let's go ahead and move on to lists, okay? See you in the next lecture. Alright, so in the last lecture we talked about strings. We discussed how we can split strings, slice strings, how strings work, and so on. And again, there are several functions that we can use with strings, and we'll get to them later in the course. But basically, I just wanted to give you a quick introduction on how strings work. Now we get on to lists. So, for example, let's say I had to go to maybe Fred Meyer or Target or any shopping store that's maybe near you. And I was creating a list. So, let's create a shopping list of the things I need to buy. And I'm going to be using a string here. So I have a shopping list. Maybe I need eggs. I might need some carrots. Oh, I need milk, cherries, and let's add one more, apples. Okay. So let's say I had to go to a shopping store and I had all these different items that I had to buy. So right now what the problem is that if I need to know what's the first item in my list, what do I have remaining, stuff like that, I can't do that with a string. Right now, if I just want to find out what's my first item, I'll have to do shopping list and then use some splicing stuff, but that also depends on if I know the number of characters. Right now, if I just print shopping list, I'm just going to get egg, carrots, milk, cherries, and apples. There's no specific way to find out what's my first item, what's my third item, what's the last item I have to get. And this is where the Python term lists and the more general term arrays comes in. So again, let's create a new list, shopping list 2.0 or 2, and let's create an array over here. And the way to create an array is we're going to be using 2 square brackets, and in the square brackets you're now going to add your items. So our first item was eggs, comma, our second item was carrots, comma, third item was milk, cherries, apples. So these lists, right, they're the most versatile data type available in Python. All the items, the items in the list can be of any data type, strings, numbers, etc., etc., but they can be. So this is our shopping list in which we've used an array. Now, for example, if I print out shopping list 2, what do I get? I get eggs, carrots, milk, cherries, apples in square brackets. And now you're wondering, hey, what's the difference between shopping list 2 and shopping list 1? The only difference I can see is that we're adding these square brackets. Well, guys, the whole point of arrays is that we can now use indexing to get our values. Whenever you create an array, and again, in arrays, you can add any value whatsoever. You could have added integers, floats, you could have added decimal values, stuff like that into the array. Right now, since it's a shopping list, I've used strings. But the whole point of arrays is they've given each value an index number. So I'm at the grocery store, and I've checked marked eggs, but I'm not sure what is my next item in my list. So what we can do now is if we do shopping list 2, and then in square brackets right next to it, 2, we get milk. So you're probably wondering, well, why didn't we get carrots? It's a second value. Well, think about it like this. Just like we talked about characters in the last lecture, with lists, it's the exact same thing. The indexing in a list, in a string, in almost all data types in Python, it starts at 0. So the eggs index is 0. If I want to know what is my first item in my list, I'm going to use shopping list 2, and then in square brackets, the first item, which is 0. If I want to find out, hey, what's my fourth item in my list? I'm going to say shopping list 2, and then n minus 1. If I want to know the fourth, it's 4 minus 1, 3. So shopping list 3, it's cherries. So this is where lists become more and more useful. And this isn't the end. There's tons of functions you can add with lists. Right now, all we've done is we've accessed values. Let's say I was at the shopping store or at the grocery store, and I'm like, wait, I don't need milk anymore. I realized I have 2 cartons at home. Instead, I need chocolate. How do I update the value in list? Right now, if we were using a string, there was no way we could do that. We'd have to rewrite the string over and over again, waste of time. However, with lists, it's quite simple. First, find the position. What's our position? It's going to be 2. So all we're going to say here is shopping list 2 should now be equal to chocolate. Do you see what we did there? All we're saying, string object does not support item assignment. The error I was getting here is, sorry about that. It's shopping list 2, since the variable name was shopping list 2. So here, in case I want to change milk to chocolate, now typing in chocolate again. And if I print out shopping list 2, we get eggs, carrots, chocolate, cherries, apples. Isn't that cool? So you can update values in lists. You can change, you can delete, you can add. These lists are the most versatile object you'll find in Python. And as we get along in the course, as we add or dive deeper into Python, lists will be one of the main objects we use every day. So play around with this, and in the next lecture, I'll be showing you some cool functions that we can use with lists. See you then. Alright, so let's get started. We're on lists now, and so far we've learned that lists are very versatile. You can add objects, you can change the object in lists, but what else is there to it? So let's go over a few main functions that are built with Python. So the first one let's talk about is deleting an item. I'm at the grocery store and I realized we have tons of apples at home. I don't need to buy anything else. How do I delete apples from my list? So the quickest way to do that would be using the del function, D-E-L, okay? As you can see, as soon as we wrote it, it's become highlighted in a yellowish color, which is great. So it's del, and then we have to specify which list. So shopping list 2, and then the position of the item. So the position of the item is the 5th, so n-1 is 4, and it now says unexpected indent. So I will discuss this in a future lecture, but indenting in Python is quite key. Okay, I'm going to tell that right now, but I'll explain it more in detail probably in the following lectures. So del shopping list 2, 4th position. Now if I print out shopping list 2, what do we get? Eggs, carrots, chocolate, cherries. So apples has been deleted. Right now, take a mental note of all the functions that we're using. So let's go ahead and quickly make a note of the functions that we're learning in our arrays. First one was the del function, okay? The del function, all it does is it deletes an item from the list. So this is key. Whenever you have an extra item or if you have an unnecessary item, you can instantaneously delete it. Next. So we haven't discussed what happens when we want to add arrays. What happens when we want to, subtract from arrays or compare arrays. So there's functions for all of that. Right now, I'm going to create two simple arrays. Array 1, that's going to have the value, let's say 23, 54, and 64, I guess. And array 2, which will have the values of 43 and 23. So if you're probably wondering here, how do I add array 1 and array 2? It's the exact same way we did with strings. So we can say array 3 should be equal to array 1 plus array 2. And by doing so, array 2, and if we now print out array 3, we'll get all 5 values. So adding arrays is as the exact same thing as adding strings. There's nothing to worry about there. Next function. So we've discussed delete, we've discussed adding arrays together. The next function we're going to discuss is len. So many times when you have arrays, you're adding object after object, object after object, and in the end you want to know, hey, how many objects have I added? What's the total number of objects in my list? That's where the function len comes in. So type with me here, len, and as you can see, it's again been highlighted, except this time purple. Len shopping list 2. So len shopping list 2 returns us 4. The whole concept of len is it returns us the length of the array. If I have 5 objects, it returns 5. If I have 15 objects, it returns 15. And once we get into loops, right? Once we understand how loops work, which will be, I'm pretty sure in the next 3 or 4 lectures, then I'll show you how we can use len to iterate through our array. There's many different ways you can do that, but we'll get to there. Now, before I end this lecture, let's discuss 2 more functions, max and min. For example, I'm going to call this array num array, and I'm going to set it as the values of 36, 75, 100, or 1000, or 10,000 for 1 and -5. So I've created a num array. It has 5 random values. Now, if you're wondering, how do I get the biggest value out of this array? And how do I get the smallest value? That's where the max and min function come in. So just like we used len, we typed len and then in brackets, the exact same way we can use the max and min functions. So max num array, sorry I can't speak today, and min num array. So by doing so, you can now get the maximum and minimum values of an array. Let's go ahead and add them to our notes. So we have del, we have len, we have max, and we have min. So again, there are tons, and again, tons of functions that you can use with arrays in Python. Alright, so before I end this lecture, let me just show you two more functions. And you're probably wondering, let's move on from lists. I'm getting bored of lists. Don't worry, this shouldn't take too long. So we discussed del, len, max, and min. Now, for example, if you want to add another object to your list, we've created this fantastic shopping list, and then you're like, oh shoot, I forgot to add broccoli. I mean, I hate broccoli, but still. So the way we can do that is shopping list2.append. The whole meaning of append is add an object. So shopping list2.append, I want to append broccoli, okay? And if you now print out shopping list 2, we're gonna get eggs, carrots, chocolate, cherries, broccoli. It's that simple. So the append function will now add objects to your list. And last but not least, we have the count function. Let's say you have an array in which multiple values are repeating. 2, 2, 2, 3, 4, 4, 5, 6, 6, 6. And in that scenario, you want to know how many times is 2 repeating? How many times is 6 repeating? Stuff like that. That's where the count function comes in. So something you can do is shopping list 2 or 2.count, and let's say how many times is chocolate repeating in my shopping list. It's going to return 1 because I've added chocolate only once. Alright, fantastic guys. So we've discussed, I believe, 6 main functions dealing with arrays. Let me go ahead and add append and count. So these 6 functions will get you a long way through with lists. There are several more that we're going to discuss as we go along with this course, but hopefully you got a basic understanding of how lists work. Again, lists are the exact same thing as arrays. If you've ever dealt with another programming language before, you must have heard about arrays, right? Arrays and lists are the exact same thing. Don't worry, they're not confusing at all. Now, in the next lecture, we'll talk about dictionaries. So dictionaries is again another very cool data type which stores values, except it's just like a key. So it has a key and a value, a key and a value. So it's pretty cool, and we'll see to that in the next lecture. Alright, so in this lecture, we're going to be talking about dictionaries. And before we even get to how to create dictionaries and all that stuff, let's actually talk about where are dictionaries used and how they work. So I'm sure all of you must have seen a map, right? Any sort of map, maybe a map of America, a map of Asia, a map of the whole world. However, in every map, you'll always see a legend, right? Now, this legend comes in the format of a key and a value. So the way it works is, suppose there's a lot of green on the map. Green means land, right? Maybe there's some blue. Blue means water. Maybe some yellowish red. That means desert. Some white, which means mountains. Stuff like that. So it's color coded. You have a key. It can be any color, any sort of value or object. And each key has a value. So the exact same way a dictionary works, and it's actually pretty cool. So let's think about it like this. Suppose I have a class of 10 students, all right? So we have a class of 10 students, and I have each student's name. So I'm going to create students, and I'm going to set that as each student's name. So I have Eric, and I have his age. He's 14. I have Bob, and his age is maybe 12. I have Tina, and her age might be 26. I mean, it's random values. And let's do one more for now. Let's do Chris. Chris. And his age is 15. So right now, just follow along, okay? Don't type this out with me. I'm just showing you an example of where dictionaries are useful and where arrays are not. So suppose we have these 4 students in our class, Eric, Bob, Tina, and Chris. And we know each of their positions, and that's all great. However, I want to find out what each student's name is. I have a list of students. Eric, Bob, Tina, Chris, Jake, blah, 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 blah. And what I want to do is, for each of these students, I want to know their age. And they're in this array. So the way I would do this is, for each position of the student, let's say I'm talking about Eric, his is the first position, I know his age is the second position, right? If I'm talking about Bob over here, I know Bob is whatever his position plus 1. So 1, 2, 3 plus 1 is 4. 12 is his age is at the 4th position. And that's the way you would do it for these 4 people. You would find out where their name is, and then you'd find out what's the position ahead of it. Suppose you have 100 students though. Let's say 1,000. What do you do then? Do you search for each student and then try to find, hey, what's ahead of it? No, that's not at all how you're supposed to do it. Well, that's where dictionaries come in. So let's go ahead and create a new students variable. And instead of using square brackets, use curly brackets. So dictionaries are actually similar to arrays in the sense of how they're written, but the only difference is a colon. For example, we're writing Eric and 14. So the way we're going to write this is Eric colon 14. All right. So this is the key. This is the value. All right. Let's do 2 more here. Let's say I want to add Bob, and what's his age? 12. So you write the key colon the value, and then we're talking about Tina. So Tina, and it's 26. All right. So this is our student's dictionary, and you know why this is neat? Well, we can now access any of these values by putting in the key. I'm like, all right, so I need to find out what Bob's age is. How do I do that? Well, it's quite simple. You put in students, and then in square brackets, you type in Bob. And as soon as you do that, it returns you 12. So just like a maps legend works, the exact same way a dictionary works. You put in keys, you get the values, okay? So the concept of this is very, very simple, and it's quite useful. Now let's think that Bob left the school, all right? Bob was a very bad child. He never studied, never did his homework, stuff like that, and he just left the school. What happens then? How do we update this dictionary? Well, guys, it's actually quite simple. All we do now is we update the dictionary. Either, in this case, let's say if Bob left the school, we'd have to delete the entry. Otherwise, maybe for a different example, let's say Bob had his birthday yesterday and he's now turned 13. So how do we update Bob's value? Well, the way we can do that is saying student, and then Bob is now, or actually capital B, is now equal to 13. So we have now updated Bob's value in our dictionary. So going back to the statement and printing it out again, we now have 13. And since we're already on the topic, let's finish off deleting a student as well. So Bob had his birthday yesterday, he had a fantastic party, and sadly, today is his last day of school. So we now have to get him out of the students list. How do we do that? Well, it's quite simple. If you remember back in a lecture or 2 ago, we were talking about the delete statement. We worked with it in arrays. Well, it's pretty much the same concept over here. What we do is we say del, and then we delete the dictionary name. In this case, it's students. And what part of students do we want to remove? We want to remove the Bob part. So the key and value of the key Bob and its value will now be deleted from the student's dictionary. So now if you print out students, Eric 14, Tina 26. So you're probably wondering, well, is this case sensitive? So go ahead and try it out. What I want you to do is just type in students and then type in Eric lowercase. Does it work? No, it doesn't. So over here, this is a fantastic error. Let's quickly go over it. All it's saying is key error Eric. All it's asking you is, dude, there's no key that exists called Eric. And the reason is our key is capitalized E. So good thing to note here is that it is case sensitive. So keys in dictionaries of Python are case sensitive. You want to put the exact key that you created up top. So if you go down here and you add Eric, then press enter, you get 14. So fantastic. I mean, we've learned about dictionaries. We learned how they work, how to delete, how to update. And in the next lecture, let's just quickly go over a few properties and functions of dictionaries that we can use. All right. See you in the next lecture. Right. So in the last lecture, we talked about dictionaries. We learned how dictionaries work, a very basic introduction on how we can use dictionaries. In this lecture, I'll just show you some basic functions that are used with dictionaries. Len, delete, keys, values, etc. that you can use to get some specific data out of your dictionary. Let's get started. The first functions that I want to talk about are dealing with deletion. Suppose we have a dictionary, and I'm going to go ahead and create, again, a student's dictionary. and I'll be quick. Okay, so Jobs, I guess, Steve Jobs, his age is 15. Mark, his age is 24. And let's create one more. His name is Avi, and his age is 14. So I've created a very simple students dictionary, and you should do so as well if you have not deleted the previous lectures one. And here are the few functions I'm going to show you. So the first function here is going to be our deletion. So let's say I have this fantastic students dictionary, and then I realized, hey, I don't need this students dictionary anymore. How do I clear all the values in the dictionary? Well, for that, it's quite simple. Students.clear and two brackets, the parentheses, normal brackets. Once you do that, students, if you now print it out, is empty because we have cleared everything in our dictionary. Next, now we have an empty dictionary. Why are we even keeping this dictionary? Let's go ahead and completely delete it. How do we do that? So we've completely cleared our dictionary. We now have a dictionary that is completely empty. How do I just delete it? I don't want it anymore. So the way you do that is using the del command. It's going to be del and then students. So now if I print out students, I get an error. Name students is not defined. So this is basically how you clear and delete your dictionary. Next. So just like we talked about in arrays, you can find out the length of your dictionary using our len function. So if I type in len students, we will now realize, hey, there are 3 key value pairs in my students dictionary. 1, 2, 3. Quite simple. And after that, let's say I want to find out what are all my keys and what are all my values. I don't care about these pairs. I want them separate. So if you want to find out what are all my keys, you're going to use the function students dot, and you can go down and do keys. So you need to add the brackets after that. So student dot keys, and it now gives us dict keys, Mark, Jobs, Avi. So these are the 3 what would you say, keys of our dictionary. Now if I want to get the values, I'd use the function students dot values, my bad, and we now get 24, 15, 14. On another hand, I would just like to tell you, as you can see, our dictionary was Jobs, Mark, Avi, but it printed out Mark, Jobs, Avi. So Mark and Jobs got switched, and this is the thing with dictionaries, it's an unordered object. This is key. So if you keep on printing out a dictionary, you will get a different result most of the time. It's not ordered. So if I said students, give me the first value, it doesn't work like that. It's an unordered dictionary, meaning there is no indexing of the objects. It's completely random. All right. Now, before I end this lecture, let's go over another 1 or 2 functions. One last one I want to go over actually is, let's create another dictionary here. I'm going to go down to students. Let me call this students 2 and change up some of the keys over here. All right, so job mar of, and it's the same keys. And let's say I wanted to add student 2's values to my students dictionary. Well, one way you can do that is using the update function. So I can say students.update, and then I can update it with students 2's that's spelled right. Student 2's values and keys. So if I now call this function students.update students 2, and I now print out students, I now see Mark of job, Jobs, Avi. So I've literally added all the value pairs or the key value pairs of students 2 to students. So that's one way to add dictionaries. Again, there's probably other ways, but this is a simple function to do it. So these are the quite main functions that we'll ever use or in this course with Python. The len function, deleting and clearing of a dictionary, getting the keys and the values, and updating one dictionary to another. So hopefully you understood everything that's going on. Again, if you have any questions whatsoever in the previous few lectures, or if you're not understanding, well, what is a dictionary, why is it update, or what is students.keys, please leave a question and I'll get back to you as soon as I can. Now, in the next lecture, what we're going to do is we'll talk about tuples. So tuples, again, is another data type that's been introduced into Python, which is not in most programming languages, I believe. But let's definitely take a look at tuples and see what they can give us. All right? See you then. Alright, so today we're going to be talking about tuples. And before we even start, let me just talk about what tuples are. So tuples and lists, both of them are actually quite similar, but with tuples, the data cannot change. Tuples are what we call immutable. And all that means is, suppose if I create a tuple, and it has a value science, maths, and 23, alright? So 3 random objects in my tuple. I can't append to the tuple, I can't delete from the tuple. That tuple will remain as it is, okay? It's immutable, it cannot change. So let's go ahead and create a tuple, and then you'll slowly understand how things work. So creating a tuple is not at all hard. For example, with lists, we use square brackets, dictionaries, curly brackets. In tuples, we use our normal round brackets. So tup1 is equal to, and then let's go ahead and put in 3 objects, maths, 23, and dogs. Alright, so this is our tuple, right? Now, if you notice with our tuple, there is no append function. If I try appending something to our tuple, ASD, I get an error. Tuple object has no attribute append. If I try to delete an object of our tuple, if I say tup1 delete and delete the maths object, what happens? Tuple object does not support item deletion. So looking at these errors, we can now tell that when you create a tuple, no matter what you do, you can't edit the objects in it. However, you can always reinitialize the variable with a new tuple, so with new data, sorry. So tup1 can now be equal to cheese. And if I now print out tup1, I will get cheese because I've set the variable tup1 to a new tuple, alright? So now that we're talking about tuples, let's go ahead and understand why do we use tuples. Well, think about it. For example, if you were getting the user's location, right? What you could do is you could store his coordinates in a tuple, and you can create that new tuple every second. With lists, however, what you do is you'd append to that list every single time a new coordinate location came. So think of tuples as an immutable object which will never change. Maybe a high score. The high score could be stored in a tuple, and whenever a new high score comes, you can create a new tuple variable. Stuff like that. But basic concept is tuples do not change. Once you create one, it's hard to edit unless you create a new variable. Alright, so now that we're here, let's go ahead and talk about slicing. Just like in lists, we learned about you can slice. So I can say from tup1 to tup5, or I can get the first object, second object. Indexation is there in tuples. So I can do something along the lines of tup1, and if I want to get the first value, I'll now get maths. If I do tup1, second value, I'll get 23, and so on. And then, just like we learned about lists, there's also the concept of slicing. So I can do something like tup1, 0 to 2. So I'll get maths and 23. If I do tup1, 0 to 3, I'll get all of them. Maths, 23, dogs. So just like in lists, tuples also have the concept of slicing. You can get the first value, the second value, as many values as you want using the slicing that we learned via lists. And before I end this lecture, let's go over one more function actually, and that's going to be the delete function. So there's no way to delete the objects in a tuple. But what if you want to completely remove the tuple? You don't want the tuple to exist anymore. Then what do? Well, just like we learned with lists, it's the exact same function, del tup1. So it's quite simple actually, there's nothing much to tuples, but once you understand what's actually going on, it makes life a lot more easier. Alright, so let's quickly recap what we learned with tuples. Tuples are an immutable object. That means that the data that you put in a tuple cannot be appended, cannot be deleted. You can recreate the variable and put in new information, but once you create a tuple, you cannot change it. Now, tuples and lists are actually quite similar in the sense of slicing and data values. Tups or tuples can hold any sorts of data values that you want, and using slicing and indexing, you can get the values that you want. For example, over here, like we did, for the first value for our tuple was maths by calling this index function. Alright? Then we learned that you can also slice and how to delete a tuple. Great! So now that we understood the basic data types in Python, I want to move on to some conditional statements, loops, and so on. See you in the next lecture. Alright, so in this lecture we're going to be talking about conditional statements. First of all, what is a condition? Think about it like this. So, for example, let's say you're thinking of creating a Facebook account. Most of you by now must have a Facebook account, but if you're still a kid like me, I still have one, but if you're less than 13, you're not supposed to. So let's think about the condition that goes in creating a Facebook account. What happens? Well, the condition is, hey, if you're older than 13 years of age, you're allowed to have a Facebook account. Else, you're not. So these if and else conditions come into play over here. Every conditional statement will have an if or an else. If the specific condition is true, do blah. Else, do blah. So we always check if the condition is true or false. If it's true, we do something. If it's false, we do something else. Let's go ahead and create a very simple if and else statement. So the way it works, if, right, we write if and then we write our condition. If 5 is greater than 2, all right, and we know it is obviously, then after the condition we put a colon and now we write our statement. So let's say if 5 is greater than 2, I want to print out my name is Bob. Okay, something, it can be anything you want. All right. So as you can see, if 5 is greater than 2, we printed out my name is Bob, and that's exactly what we got. 5 is greater than 2. Now let's bring this back one more step. So if 5 is greater than 2, print Bob. What if it's not? Else, what do we want? Well, let's think about, if 5 isn't greater than 2, then let's say, print the earth has collapsed. Alright? So obviously, now if you think about it, 5 will always be greater than 2. So this else statement will never be run. Conditional statements always work on the true and false capabilities, right? If this is true, only the next statement will get printed. Else will be completely forgotten. This will not even be considered. However, if this 5 greater than 2 or this condition is false, then we go straight to else and see what the print statement is. Alright, now let's go ahead and execute the else statement. If 2 is greater than 5, alright, print my name is Bob, else print the earth has collapsed. The earth has collapsed. Fantastic. So this is a very simple if and else statement, okay? This is where we're checking if a condition is true. If it is, we're printing out my name is Bob. Otherwise, if the condition is false, we're printing out the earth has collapsed. Alright? So fantastic job. Basically, this is just a quick introduction into conditional statements. In the following 2 or 3 lectures, we're going to talk about logical operators, alright, relational operators, and then we'll delve deeper into nested if or else statements. See you in the next lecture. Alright, so this lecture I want to devote to operators. Right, in the last or actually in the previous few lectures, we've learned about our normal operators, which were addition, subtraction, multiplication, division, and so on. However, in this lecture, we're going to be talking about relational operators. So going back to our if statement, alright, I'm going to create that same if statement again. If 5 is greater than 2, print hello. Alright. If 5 is greater than 2, print hello, we get hello. However, over here, I want you to know what is this, right? This 5 greater than 2. What does this greater sign even mean? Well, this is what we call a relational operator. These relational operators help us to compare and contrast values to get a Boolean value. So, a Boolean value, I'm sorry, I haven't explained this before, is a true or a false. So every time we use a relational operator, we'll always get a Boolean value back, either a true or a false. It's actually quite neat. So in all, there are six relational operators in Python till date that I know of. And these are greater than, less than, greater than equal to, less than equal to, and not equal to. So let's cover all 6 in this lecture, and then we'll move on to some more complex if and else statements. First, greater than. So as you see already up top, we've discussed what is greater sign. If you do 6 greater than 3, you'll get true. If you do 3 greater than 7, we'll get false. So the greater sign compares to see if this value, the first value, is greater than the second value. Obviously you know that, so I'm not going to talk too much about the mathematical part. I'm just showing you what the operators do. Next, less than. So we have 4 less than 8, true. We have 3 less than 1, false. So this is greater than, less than. We can compare to see if an object is greater than or less than the other object. Now we come to greater than or equal to. So what greater than or equal to checks is, hey, is this object greater than this or is it equal to this? If either one of these conditions is true, then it will return true. Alright, so let's go ahead and check it out. If 4 is greater than 4, we get true. Because even though 4 is not greater than 4, it's still equal to 4, and that's why we got true. The exact same way we can check if 5 is less than or equal to 6, for example, it's going to return true. And if you do 5 is less than or equal to 5, we still get true. But because even though 5 is not less than 5, it's still equal to 5. Fantastic. So we've covered 4 of the 6 main relational operators, and the last 2 I believe are the best 2 operators. First one is the equal to equal to. So let's go ahead and create an if statement where we're comparing 2 of the same numbers. So if 5 is equal to 5, okay? If 5 is equal to 5, and we get an invalid syntax. So this is key, alright? It says invalid syntax, and you're probably wondering, what's wrong? All we're saying here is if 5 is equal to 5. I mean, there could possibly be nothing wrong in this statement. However, think about it. When we're initializing a variable, what's happening? If I create a variable called apple and set it equal to 5, what am I saying? I have created an instance of something and I'm setting the value of 5 to it using an equal sign. The exact same way Python thinks. What Python is seeing here is you're setting the value of 5 to 5. This equal sign means you're assigning the value of B to A. You're not comparing, you're not contrasting, you're setting the value of something to something else. And that's not what we want. This is where the double equal sign comes in. If 5 is equal to 5, alright, if you use a double equal sign, that specifies that you're comparing and contrasting. You're just checking to see if the value 5 is equal to the value 5. Obviously it is, so let's go ahead and print out hello. And we're gonna get hello, alright? So the double equal is used to compare and contrast to see if the values are the same, and the single equal is to assign a value. Remember that because it's going to come into use a lot in the following few sections. So the last relational operator is the not equal to. And all this checks to see is to make sure object A is not equal to object B. For example, if I say 4 is not equal to 6, I get true because 4 isn't equal to 6. If I say 4 is not equal to 4, I get false. Alright, so we're finally done with relational operators. We've discussed all 6 of them: greater than, less than, greater than equal to, less than equal to, double equal to, and not equal to. And all 6 of these relational operators will be used in our future lectures when we deal with more complex if statements, else statements, loops, etc. So go ahead, play around with these operators, get a feel of it. Again, instead of numbers, try using variables. Create a variable called num1, you can set that equal to 5, num2, you can set that equal to 6, and you can compare and contrast these different variables. So all I want you to do is get a hang of these relational operators, make sure you understand what each one of them does, because in the future we'll be using them a lot. So fantastic job, and in the next lecture what we'll do is we'll cover some more complex if and else statements. And actually, before we even get to that, I want to talk about indexing or spacing in Python. See you then. Alright, so in the last lecture, we talked about relational operators. We discussed about the 6 operators: greater than, less than, greater than equal to, less than equal to, equal to, and not equal to. So these 6 relational operators are used in if and else statements. Now, before we get to loops and what they do, I quickly want to go over nested if statements. So far, all we've discussed is if and else statements, and we've understood how they work. In this lecture, what I want to do is, again, nested if-else statements. I want to go over that. And then we'll also go over another type of if statement called elif. Okay? If, else, elif. So let's get started. first thing first, nested if statements. So I'm going to create a very simple if statement right now. First, I'm going to initialize a variable called age and set it equal to my age, 14. And now what I'm going to say is, if age is greater than 13, I want to say print you are eligible for Facebook. All right. So like we've discussed before. And as you can see right now, you are eligible for Facebook. Fantastic. So we created a very simple if statement over here. We just check to see if the variable age is greater than 13. Now what I want to do is I want to say, hey, if the age is greater than 13, all right, if that's true, fantastic. Then I also want to check for if the user's name is Bob. If it's Bob, you get special privileges. If it's not, then print the regular eligible for Facebook. This is where nested if-else statements come in. Let's take a look. So over here, once I do if age is greater than 13, instead of doing the print directly, I'm going to put a new if-else statement. If age is greater than 13, if name, so actually before we do that, let's go ahead and initialize my name variable. So, all right, it looks like it's not letting me delete that. So let me go ahead and create a name variable. Set it equal to Bob. All right, so if age is greater than 13, now we put our second if statement, which is called a nested if statement. If name is equal to Bob, then what do we want? Print, whoops, you get special privileges. All right. All right, and now let's go ahead and add the else statement. So if name is equal to Bob, print you get special privileges. Else, print are normal, you are eligible for Facebook. Print you are eligible for Facebook. All right, so now if we run this, we get you get special privileges. So this is the concept of nested if-else statements. Basically, all we're doing is we're adding one if statement under the second. And you're probably wondering, how do I know if it's nested or not? That's where the spacing comes in, all right? So right here, we can see that if age is greater than 13 is the highest in the order. That is that this is the biggest index so far. Then you can see that this if and else are the next subclass of if. And then after that, print is part of this if statement, and this print statement is part of the else. So spacing or indexing, I'm not sure what you'd call it here, is quite key in Python. You need to make sure that your spacing is right. So if we had done the print statement over here, okay, it would have done, we would have done an indexer. So over here, if I backspace this print, and now if I hit enter, you get syntax error, expected and indented block. So these indents are actually quite key in Python. Again, that's something you should know. So whenever you're writing Python code, normally it'll do it for you. But if you're writing maybe an HTML doc or something, then make sure you get your indentation right. All right, so let's go ahead and end this lecture over here. In the next lecture, we're going to talk about elif statements. So this lecture we learned about nested if and else statements. I thought that was pretty cool. Now what you can do is you can put multiple if and else statements in one bracket of code. Fantastic. See you in the next lecture. Alright, so in the last lecture we left off with nested if and else statements. This lecture we're going to talk about elif statements. So let's get started. First off, we've learned that if and else statements work on the following basis. I can say if, or first of all, let me create a variable. I'm going to call it day. Day is equal to, today is Tuesday, so I'm going to go ahead and put in Tuesday. Alright, whoops. Okay. Day is equal to Tuesday. Now, let's say I'm checking for each day. So if day is equal to Monday, then print sunny. All right. And now I do a simple else statement over here to specify, oh, whoops. My bad. Again, my bad. All right, one sec. So else print rainy, okay? And for the specific, the basis of this program, it works fantastic. If day is equal to Monday, which it's not, it won't print sunny, it's going to print rainy. However, what if I wanted a specific case for Tuesday? I have if day is equal to Monday, Monday is a possibility, but what if day is equal to Tuesday? I know that on Tuesday, it's going to be cloudy. but based on this code, Cloudy will never come. How do I make it so that Cloudy comes? Well, this is where elif statement comes in. And if you've already guessed it, elif stands for else if. So basically, it's another if statement you can add. So let's do this. If day is equal, let me just bring this down over here. Actually, that's fine. If day is equal to Monday, all right, this is our first statement over here. I want to say print sunny, right? Now, else if, okay, elif day is equal to Tuesday, I want to print cloudy, okay, this is our second exception or second condition. And otherwise, if none of them are true, then I want to say, I want to print out rainy. So think of elif as another one. Oh, okay, sorry about that. Looks like it's a spelling mistake. I spelled Tuesday wrong. Tuesday, my bad. So now if you enter this out, we get... Wait, what? Oh my god. Okay, my bad, guys. I spelled day wrong, or I spelled Tuesday wrong and day as well. So if day is equal to Tuesday, all right, let's get that straight. And then let's bring this if statement down and run this again. Cloudy, yay. So this is the whole concept of elif. For example, if I have multiple conditions I want to go through and it's not being done in my simple if and else program, what I can do is I can continuously add more and more of these elif statements. These are basically, if this is true, do this, else if this condition, then do this, else if this condition, and so on until you get to an else where if nothing else, if none of these options return true, then do the else. So you can play around with the elif. You can create some very simple, what would you say? Some simple if and else or elif statements, and yeah, fantastic. There will be some exercises again at the end of the section where you can quickly go through your what you've learned. If you want some practice with this if and elif stuff, definitely take a look at the exercises. Otherwise, let's move on to the next lecture, which will be about loops. See you then. Alright, so today we're going to be talking about logical operators, and so far we've discussed arithmetic operators, the plus, minus, divide, and multiply. We've talked about relational operators, we've greater than, less than, equal to, greater than, equal to, and so on. And finally, we now get to our logical operators. So I wanted to cover if statements and else statements before we talked about logical operators, because that's where we actually use them. So I'm going to create a quick if statement over here. So first let me initialize a variable. I'm going to do another age, and if age is greater than 13, print you are eligible for Facebook. So again, this is the same example we used before, but I want to show you something here. So let's say I have this fantastic if statement, okay? If age is greater than 13, print you are eligible for Facebook, everything works and it's fine. What if I wanted to check for more than one condition in my if statement? For example, if the age is greater than 13 and his name starts, or if his name is Avi, then he's eligible for Facebook. If his name is not Avi, then he's not eligible for Facebook. How does that work? Well, this is where logical operators come in. What we can do is we can say if age is greater than 13 and the second condition. So if age is greater than 13 and name is equal to Avi, I know we haven't initialized the name variable yet, but that's fine. Print out you are eligible for Facebook. Eligible. So today was an error, name is not defined, and so on. But here I just wanted to show you how you can use logical operators in if and else statements to add more than one condition in the same line. So let's quickly cover what logical operators there are. There's actually two, and or. So for and to work, for and to return true, condition 1 and condition 2 must return true. It can't be that this one is false and this one's true, or this one is false and this one, I'm not sure what I'm saying. So it can't be this one is true and this one is false, or this one is true and this one is false. Both the conditions must return true for the statement to work. However, with or, let's go ahead and initialize a name. I'm going to call myself Bob. So
let's go ahead and bring this statement down. If age is greater than 13, or, does the letters change? Yes. If age is greater than 13 or name is equal to Avi, print eligible. Now if you notice, it prints out eligible. And you're probably wondering, well, name isn't equal to Avi. How is this working? This is the case with OR. With OR, it doesn't matter which condition is true as long as one condition is true. For example, age is greater than 13. My age is 14. 14 is greater than 13. However, name is false. This condition returns false. But since there is a true, since this condition is true, no matter what the case is for the second one, this can be true or false, we'll get the eligible statement printed out. So this is the thing with and or logical operators. You can use them in your if statements, else statements, wherever you want, but they allow you to add more and more conditions to what you already have. Whenever you're creating an app or whenever you're doing Python coding, if you have multiple conditions you need to check to, you can do it all in one line. Alright, so this is basically what I wanted to cover for this lecture, and now we're finally done with operators, and I'll see you in the next lecture.